Coming up on This Week in Radio Tech, we're talking with a real engineer who's also the president of Dielectric. You know, they make antennas, not just TV antennas, but lots of FM antennas as well. And I got to tell you, they have been doing some incredible research into new FM antenna designs and new way to rearrange old designs. There's some cool stuff coming up in this show that will really open your eyes about FM transmission antenna technology. It's coming up next on TWiRT.
This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support. Online at bgs.cc. By Broadcast Bionics with the Bionic Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Air, featuring Playout One radio automation software, comprehensive streaming solutions, website content management, and social media tools for maximum listener engagement on the web at AIIR.com. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts.
Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to that light bulb from the top of the tower. Hi, I'm Kirk Harnack. Delighted to be with you here just a week before Thanksgiving in the USA in the year 2025. It's our 775th episode. My goodness. And glad you could join us. We've got a real meat and potatoes technical episode today that I'm really thrilled to bring you, because this is a topic. And our guest, I saw this guest and his presentation at the Wisconsin Broadcasters Show, and I thought, this is really good stuff. This needs to get out to engineers, and a lot of you are going to be interested in this. And it's about antennas. It's about FM antennas and the improvements that are still being made in FM antenna design. So I've kind of wet your whistle a little bit. Let's bring our guest in. It's Keith Pelletier. Keith, great to see you. Welcome into the show.
Great to see you as well, Kirk, and I'm very honored to be part of the 775th show for TWiRT.
So I'm pretty intrigued here. You are the president of Dielectric, and that seems like a big job, big responsibility. You're probably charged with signing checks and all that kind of stuff, but you're also an engineer. I mean, it's not every day we see a by golly design engineer become the president of a company that makes technical things. So tell me just a little bit about that and how you got to where you are.
Sure. So I started my career in 1997. I went to the University of Maine. We're located in Raymond, Maine. So I was looking to stay close to home, save some money for an internship. And Dielectric was in a lot of need to get through the digital television repack at that time. So didn't come with a lot of RF background, learned a lot of that from the more senior group that was here at the time. But then, spread my wings, learned about the engineering throughout our product line, became vice president of engineering, and then eventually got put in charge of running the entire group.
Wow. Okay. Wow. I'm delighted to see an engineer doing so well, especially at the top of a company. And before we get into the meat and potatoes of our topic, which is some innovative new designs of FM antennas and improvements on old designs, tell me a bit about I had on the tip of my tongue here about. Doggone it. I can't just right out of my head. So Dielectric. Oh yeah, that's why I wanted to ask you about the ownership of Dielectric, because I heard, 10, 15 years ago that Sinclair, major TV broadcaster, they own, tons of TV stations, that they ended up buying Dielectric. And I just wanted to see, what was that dynamic like, and what was the circumstance behind that?
Yeah, that's a great question. So Sinclair Broadcast picked us up in 2013. We were previously owned by SPX. SPX did a lot of stuff in automotive, food processing. We didn't really fit into that portfolio. So at one point, they shut us down, and Sinclair was our top customer at the time. and had been for many years. So they use solely dielectric equipment, have since, and they were in a major issue with a large antenna system that we had built, 25 years ago, that was having some issues, and they needed our expertise. So at the time, they stated, we're going to pick these guys up for an insurance policy, make sure that, all of this stuff that they're building, we continue to get their product because we believe they're the best in the industry. Their engineering is second to none. But as we moved forward and we did the repack and some of the stuff that we're doing in FM, they realized what a gem that they had, and we've been able to produce quite a bit of revenue to the bottom line in support of those efforts.
Gotcha. And I guess I understand that the switch to digital back in the early 2000s, and then the repack that just finished, about 4 or 5 years ago, those generated a huge amount of business, and I think it's great that you guys have really put effort back into research on FM antennas, which is what we're going to be talking about here. Am I about on track with that?
Yeah, absolutely. And just to go a little bit in history about where we've been with FM antennas over the past couple decades. We talked about that a little bit before the show started, and my feeling on it is back in the day. So our roots come from RCA and also Harris Broadcast. Along the way, we've acquired different groups, but if you look back, way before my time, RCA had a group that was the VHF group, which FM was part of, and a UHF group. And those two groups were very competitive, and they did not like each other one bit.
Oh, wow.
So I think a lot of the culture was, separated the engineering between the two. And the sad part about that is we're just designing, FM and TV. It's very, very similar. So what techniques in UHF, you can cross those over into FM and vice versa, and make your portfolio so much stronger. The linchpin is those groups did not get along, so they were competitive and trying to outdo each other. So when you look at the culture of when the RCA guys came up, and it was right before the first digital transition for TV, that was our focus. And the sad part about that is, if we did what we were doing now, we would have stayed a pretty big force in the FM side. So that the culture, and trying to get everybody on board for what we're trying to do now, and then show the team that it's as I say simple, but not really simple, but we're doing the same things in TV that we should be doing in FM and vice versa. And that's really what's gotten us so much stronger in the FM side. And people are starting to recognize it.
Gotcha. All right, cool. Keith Pelletier is our guest. I'm Kirk Harnack on This Week in Radio Tech, and we've got real meat and potatoes. We've got most of what Keith showed at the Wisconsin Broadcasters Clinic about FM antenna design and improvements in design, and some of these are really innovative. I want to say gobsmacked, but I was at least, standing there with my jaw open watching this presentation, and you, our good guests, our good audience, you're about to see this coming up in a few minutes. Our show is brought to you in part by AIR, AIIR.com, makers of Playout One, but also they're offering radio streaming for your radio station, and it's a great deal. Let's check it out. Hey, it's Kirk Harnack, and I'm here with Ricky Lee, the CEO of AIR. Ricky, you guys make a fantastic automation system, but streaming is a really big deal. Tell me about streaming with AIR.
It really is. We've got a beautiful streaming platform with an incredible dashboard with fantastic analytics. And you can buy it for just $20 a month. All you can eat. No limits on bandwidth or bit rates. And you can also record shows as well. So if you like to deliver on-demand content for $20 a month, you can stream and deliver that on-demand content to an RSS feed that can feed your radio player, your mobile apps, or a podcast that people can download and enjoy.
Now, $20 a month, that must be for just some slow MP3, right?
No, MP3, AAC, and we also now support HLS, which is big in the industry right now.
Wow, that's pretty amazing. How do I start to explore or find out more about streaming through AIR?
You go to air.com, AIIR.com/streaming. And from there, with a credit card, you can sign up and get started.
It's a great deal. $20 a month for each station. Wow. And Air does so much more. They have Playout One, and you have mentioned many times my 21 stations use Playout One, and we love it. Also, they do content management, CMS, for your website, your radio station website. And they have listener interaction on one smart screen. You can see texts, SMS messages, WhatsApp, emails, and all that on one screen from your listeners. So it really helps you with your on-air production. So lots of tools for you from Air, AIIR.com. Thanks so much for sponsoring This Week in Radio Tech. All right, let's jump in. I know I keep saying meat and potatoes. Well, I want to see what this presentation is all about. Keith Pelletier is our guest. And Keith, you're welcome to go ahead and just jump right into this. We'll follow along, and Suncast will follow your instructions as to changing to the next slide, if you like.
Sure. So what we're going to cover is, three of our antenna developments that we've done recently, and showcase, some of the benefits and why we pursued them. So the first one is our DCPC panel, and what the original goal here was or how I challenged the engineering team. If you look at, with the tower crews and the broadcasters, they want something that meets all their electrical and mechanical goals. Mm-hmm. However, they want it as simple and reliable as possible. So if we go to the next slide, the goal here with this panel antenna is typically, if you look at the top picture, you either have quad dipole panels or dual input panels. And if you look at the feed system, they're very robust. I mean, they're very complicated, multiple power dividers, multiple cables going to each panel. And, it's all about reliability. And how do you get these products more reliable? You take out, parts counts, make it a lot more simple. So our goal with the DCPC was to have a single input. So you cut your feed system in more than half. The rig and crew has a lot less to install. Cables and cable lengths become vastly easier. So if we go to the next slide, I won't bore you with all the Maxwell equations and all the stuff that we actually did, but we said, in order to do a single input design, there's a lot of bags in our tricks on calculating, how to get more bandwidth. So we increased the size of the DCP-J panel on the DCP-C, and that automatically gains you a certain amount of bandwidth. But both pattern bandwidth and VSWR. That's just one step of the equation. We also added a shorting stub in the antenna element. And you can kind of see, if you go from left to right on the VSWR plots, the VSWRs keep getting better and better and better. Mm-hmm. So again, we added a parasitic element to this, and the VSWRs just dropped down dramatically. So now our feed system is about a third of what a traditional broadcaster needs for a panel type antenna. These are big systems, and the benefit here is just it's easier to install. It's going to last a lot longer moving forward. Some of the other techniques that we looked at for pattern bandwidth is we rotated the if you look at a single input element, the ratio of the arms from one side to the other is what defines your HV ratio. Oh yeah. So your HV ratio is going to walk throughout that band. But if you use a simple technique of rotating every other panel, the panel then becomes, your H becomes your V becomes your H. So now you stabilize the horizontal and vertical across the band, and you've got we met our goal of being able to produce a panel that's got a single input. And again, it's utilizing all these tips and tricks that we learn, and also trying to cross-pollinate between TV and FM. That's how we've really been able to get some of these techniques through. So in this particular case, we have, actually, we've got an order in house right now for a 6-bay panel. So not only have we done a lot of innovation of the design, put it out to the marketplace, but a lot of the topics that we're talking about today, we actually have in our shop. So it's pretty exciting. We had a customer visit. We called it Radio Vana, and we invited about 60 guests of the top broadcasters in the U.S. Canada was represented, Brazil was represented, and we did that in June. So when we introduced all these products, they were brand new to the industry. It showcased our strengths and collaboration on, hey, look, this is how serious we are about FM. And the interesting part about that is, fast forward 5 months, all these products are in our shop right now as orders. So it's very exciting times for us. We're very proud of what we've been able to do and showcase our strengths to our end users. So if you go to the next slide.
Yeah.
So we basically increased our reliability due to reducing the complexity and number of components. Power dividers are less, feed lines are less. The Ballon tube is just a single Ballon tube. The actual height of this is a lot lower too. So taking abuse from the mechanical abuse of being up on a tower with high winds, ice, everything is just a lot more reliable. It is a patent pending design. And like I said, we've got one in the shop right now. So that's one of the 3 products that we're highlighting in this show today.
This is always one of my concerns, and not that I can do anything about it, but when you have an antenna, typically a multi-station panel antenna, way up there with a lot of parts and a lot of cables and the power dividers and all this stuff, you just have so many potential points of failure. And if an installation crew gets something wrong, doesn't do something up to good workmanlike, or, if it just gets hit by a chunk of ice, then, or a falling satellite, whatever, then you can have some reliability problems there. Things can break. And by reducing the number of the power dividers, feed lines, and Ballon tubes, just by more intelligently designing the working parts there, and then by arranging them, I love how you flip them to get to get a good horizontal vertical ratio. Because one outdoes the, one compensates for the other. That's just brilliant. I think that's just a great way to do it, and reducing components way up there is a great goal.
Right. Yeah, absolutely. And there's very good, we talked about this earlier too, is that there's very good tower crews out there that are doing really good work. But if you can make their job easier, it's quicker to get them on the broadcaster on the air, and everybody can breathe and with a sigh of relief that it's done and it's done right. It also helps our guys on the manufacturing floor, right? If you're starting to simplify this, that they're not 1,000 feet in the air or 2,000 feet in the air, but it makes their job a lot easier, and everybody can rest easy knowing that this product's going to last a very long time.
Gotcha. All right. What's next here as we move along?
All right. So our Ringmaster, the Ringmaster is actually one of the hottest items in our factory right now, and it's really taken off and almost in a life of its own. So what we did with the Ringmaster is, traditionally, we can go to the next slide. Traditional antennas, and again, this presentation was a lot longer, but for simplifying it for this audience, we have most broadcasters are not broadcasters, but manufacturers out there do a traditional full wave array, and then they have a half wave array. The half wave arrays, the 2 components that really drive those are, you increase the bandwidth significantly, so you can multicast many channels off the half wave design. It also gives another benefit of low downward radiation. So essentially, the vectors that go up and down are canceled by the half wave flipping of the array. So those were the real 2 common deployments for many FM stations around the globe. So the challenge here to the engineering group was, what happens if we do a combination of the 2? And you carefully look at your elevation pattern results, because you can't do it everywhere. But where can you do it to maintain the same bandwidth of the half wave, but have higher gain so that you use a lot less, again, reliability. It uses a lot less parts by doing a combination of the two. So we went through an engineering exercise of really trying to figure out if it was possible, understanding that, if it does, say an 8-bay full wave is a 16-bay half wave relatively in gain. So if you had a broadcaster that wanted to multicast on a 16-bay half wave, can we do it with a 12-bay array, which is a lot more economical to the broadcaster? So the cost of ownership is a lot lower. And also the parts count is down. It's easier to install. It's easier to get them on the air. So if we go to the next slide, if you look at the different, this kind of just goes through some of the combinations of what we've been able to do. But if you let's take the 16 bay. So if you look at the far right number of bays and then the spacing combination. So think of it this way: if you have 2 quarters and you're flipping them heads or tails, the amount of combinations that you can get is 32,766.
Oh, wow.
So what we've done is said, okay, there's that many different combinations. Which ones of those can we use to get more bandwidth, to get similar gain of half wave arrays with using 33% less components? And that's exactly what we've done. So not every combination is going to be useful to the end user, but what we've been able to do is narrow down which ones are, and those are what we're deploying to the site now. And Kirk, we've got probably 24 deployed, and there's another 5 or 6 in our backlog right now, and we're quoting them every single day. So this has been huge breakthrough for us. This technique has been working out great. Lots of good feedback from all the major broadcasters that are utilizing them about performance, ease of install, and how they're utilizing these versus the traditional methods.
Yeah. I have a question about the difference between a center fed and an end fed design there. If we can go back and look at that slide, I noticed that the center fed, you've got symmetry between the top and the bottom halves, whereas with the end fed, you don't have that symmetry. Why is that symmetry important for the center fed?
Well, actually, in these examples, we're showing them symmetrical from the, either what we call a dual center fed or the center fed, but we've also produced them where they're not symmetrical, where you got a half wave pair on the top half and everything's full wave on the bottom. So it's all about, what's the customer's gain, what's their bandwidth, and then we narrow down the different options that they can utilize them in. And one thing that I like to say, one thing that I like to say about the Ringmaster, we're not, we're taking every single broadcaster's needs into play, and we're not necessarily saying Ringmaster, Ringmaster, Ringmaster for all these applications. There's applications where half wave and full wave still meet the need of the broadcasters, and we're deploying those systems. But there's a lot of times where we can take advantage of some of these techniques and deploy a Ringmaster. So it's just another tool in our tool belt that we're able to specifically design for a site. That's one of the things that we do really well, is take in all the site requirements, look at, how do we design these sites, what's best for this site, and we don't build anything we hardly ever build a site the same, because the customer sites are all different. Even if it's for the same end user, a lot of the applications that we take in, we design for the site, which really helps the end user at the end of the day. It makes our job a little bit more difficult to go through all those steps to make sure that we're designing exactly what we need to. But that's kind of what Dielectric's been built on for many, many decades.
Gotcha. Okay. Well, this next slide even takes these ideas a bit further, doesn't it?
Yeah.
Really
so this slide it's kind of like a recap. So if a customer has 85 feet, they need a specific gain, they need a specific bandwidth. The traditional way of meeting this requirement would be an 85 foot 18 bay antenna, right? So it's a lot of bays, a lot of parts going up there. With the Ringmaster, we can take that same requirement and say, okay, we're gonna jockey up the bays between half wave and full wave, produce a 90-foot antenna, which is basically the same aperture as the 85, and get the same bandwidth characteristics. And you can see the feed system on the Ringmaster is a lot less complicated than it is on the 18 bay. Plus, there's 6 less bays. So there's 33% less radiators in the Ringmaster. And then the other thing is the half wave space. Clearly, the vectors from plus and minus 90 degrees cancel each other out. So you have really good downward radiation characteristics. The other thing that we can do here to make the 12-bay Ringmaster a little bit more, have better downward radiation characteristics is produce an 80-foot antenna, which is probably slightly less gain than the 85 because gain's all about aperture, how much aperture you use. But that 80-foot antenna that's shown on the right has good downward radiation characteristics, and again, 33% less radiators.
Wow. And so what, do you have any numbers either in your head or before you that would indicate how much difference in the transmitter power output would I need for these different lengths of antennas? You said there'd be some difference in gain between the 85 and the 80-foot, for example.
Yeah, so I mean, you're probably talking less than 5% delta. So if it's a 30 kilowatt transmitter or a 25 kilowatt transmitter, it's going to fluctuate by 5% one way or the other.
Gotcha. But this 33% less, or wow, less radiators. Keith, hey, we're going to take a pause right now. I know that the next slide is pretty exciting. It's got a great picture on it, and I want to wet everybody's whistle to stay tuned because we've got more from Keith Pelletier, president of Dielectric. We're honored to have Keith on the show today to explain this, and there's more explaining to do. So stand by. It's coming up. It's This Week in Radio Tech, episode 775, and our show is brought to you in part by our friends at Broadcast Bionics. Wow, do they make some cool things. I was just talking to one of their customers earlier this week about the tools that they use in their control room to make their stations sound better, make their jocks sound smarter, their presenters sound smarter, like they have lots of information at just right at hand that comes up. A lot of it just comes up automatically depending on what they're talking about. Let's check it out from Broadcast Bionics.
Welcome to the Bionic Studio. The Bionic Studio brings all audience interaction to the fingertips of a production team in radio, TV, and podcast. Our workflow-led system is working 24/7 around the world for small broadcasters and national and international networks. Our telephony module, Bionic Talk Show, allows cost-effective centralization, remote operation, scalability, and resilience across an entire network of stations, but at the same time is used in single-studio self-op environments. Social media curation and activity is now considered a broadcast-critical part of programming. Bionic Social means the studio isn't overwhelmed with a wall of interaction from an ever-growing number of social platforms. We combine SMS, MMS, and email together with a speech-to-text service for listeners using smart speakers. We enable studio teams to curate, filter, and display all platforms in one place, and post text, images, and video content to multiple platforms in one operation. Effortless collection of video content with Bionic Director has helped position some of the world's most successful stations as leaders in viral content, generating appointments to listen and free marketing via retweets and shares. Bionic Contest enables end-to-end tracking of on-air competitions, live reads, and prizes. These could be on-air contests, automated SMS entry, or online. Anywhere, and Skype TX for Radio brings high-quality audio and video contribution into the studio with ease. No need for dedicated PCs to run different applications. Everything is controlled within the Bionic Studio UI, and incoming connections are visible to users along with all other platforms. Our codec integration enables connection, algorithm configuration, and directory to a wide range of IP and ISDN codecs. The Bionic Studio, a unique suite of products designed to enable your talent to work smarter.
Oh my goodness, you can save the day, engineers, by recommending some of the Bionics products to your broadcast facility. They really make some very, very cool stuff. Check it out from Broadcast Bionics at bionics.co.uk. They have dealers all around the world And so you need to check it out in your country, wherever you are. Hi there. It's episode 775. Wow. I'm Kirk Harnack on This Week in Radio Tech. I'm in the TELUS Alliance studio, if you couldn't tell, here in Nashville, Tennessee. And our guest today is Keith Pelletier. He's the president of Dielectric. I never thought I'd be talking to the president of Dielectric. So this is a pleasure. And Keith is an engineer. So he knows what he's talking about, right? Keith, I kind of teased the fact that we had a really cool picture coming up here. This is amazing. I mean, this looks like something from outer space or another planet. Tell me what we're looking at as we get the picture online. There we go.
Yeah, so this is, we talked a little bit about the Radio Vonner event where we brought a bunch of customers in. That was, some classroom stuff that we did on the lake here for a few days, and then we had the customers come to our facility. But this is really exciting. This is a 16-bay half-wave space ringmaster that we showcased at the site, which has since gone to, at the Dielectric site, which has since gone to Salt Lake City on top of Farnsworth Peak. So we originally were looking at doing a 12-bay ringmaster here, but they wanted to add 13 stations. So you got to start worrying about peak voltages, the average power. Farnsworth Peak is about 10,000 feet above the ground too. So you got a lot of things that are fighting against you. So we settled on doing a 16-bay ringmaster. And what's very exciting about all of this is you can see the VSWR performance when we were all said and done. It's a 1.1 or better across the entire FM band from 88 to 108. So what does that mean is that as the 13 stations go into this, they all have relatively equal power reflected coming back, which is very minimal specifically for a side mount traditional ring antenna. Mm-hmm. We could probably go into a whole different episode in the future about our combining, but our combiner here was a 13-station manifold combiner, which traditionally, when you get up to these amounts of stations or anything above 3, most competitors will avoid doing a manifold combiner. What we've developed is what we call a reconfigurable manifold, which is also patent pending, like the Ringmaster, the DCPC, and the last product that we're going to showcase on this. You're able to remove stations. You're able to upgrade, meaning add stations to that 13-station combiner in the future with all the engineering that we've done up front, and repair a station while the other 12 are still on the air. So it's really cool. It's really cool technology. I know I'm kind of veering off here, but all this stuff that we've been doing in FM really excites me. It's something that I've been trying to do with Dielectric for a long time, and a lot of things are coming to fruition here and advancing us as we go. So this is a really, really cool product. The Ringmaster itself, we've got big systems in Dallas, San Diego, Florida, here in Salt Lake City. So this product is really unique to us, and something that we're very excited about. And the entire Dielectric team understands the advantages through it. So as we're starting to showcase these with our sales team, our engineering proposal team, and then as it goes through the factory, everybody's on board, which makes, ensure that the broadcaster is going to get what they bought and a product that can last for a very long time. So a very, very cool project for us, as you stated. So we're very pleased with the outcome of that and the performance that it's doing in Salt Lake City today.
What are some of the things that can upset the balance and the tuning of this system? Like if you installed this and they swept the thing from one end to the other and looked at the reflected power, and all of a sudden a couple of the stations that were supposed to be in here nice and low, all of a sudden had a higher reflected power. What are some of the balancing points in a system like this?
So that this particular one, they're fed in half-wave pairs. So those half-wave pairs, because a half-wave antenna, essentially, the bandwidth of a ring-style antenna is defined by volume. When you half-wave space them, they get so close to each other, they start to look like one. So that's why you can get a lot of bandwidth out of a FM ring style. So, but each one of those pairs needs to be tuned with what we call a slug to keep them at 50 ohm J0. So one of the things with the Ringmaster, we talked about less parts, less tuning points. It's easier for the installer, but we'll go through each one of these and we'll solder the slugs in place, and we'll also stake them to the bullet so that you can't invert the slug, which would affect your overall tuning. And some of the FM band would go away by doing that. Less parts also helps with that. If you look closely at this feed system, we're also doing a lot of match marking and color coding. So it really makes, with the installation drawing sent to the riggers, it really makes it, dummy proof to be able to make sure that what we got here, they get in the field. I think it's once. I was just going to say, once it gets into the field and it doesn't look the same, it's like finding an Easter egg, right? In a giant haystack. It becomes very difficult. A lot of people at the factory trying to help and support it, but you're wasting days at that point to be able to find it. In most cases, we do, if that happened in the past. But everything that we're doing is trying to eliminate that for the riggers, for the broadcasters, and obviously for us. It makes us sleep better at night as well.
One of the things I think is just magical about RF, whether it's maybe TV, but certainly we do this in FM a lot. We even do it with some AM radio stations. We take the output of a number of transmitters and combine them together. And maybe we should do a show on combining it. That's a fascinating topic as well. And when I had tried to explain combining to, non-technical friends and family, I tell them, well, each transmitter has to believe that it's the only one there, that it knows nothing about all the others. It's got to believe it's alone. And then we take all those different signals, all that power, and shove it up a transmission line. And with some antenna designs, 2 transmission lines, I suppose, and shove it up to the antenna where it gets divided back out again, not by station this time, but by power. So we take the power, we divide it in half, divide it in half, divide it in half, and each of those has all the stations involved. And Keith, I just figured out something. I'm not sure if I should be proud or embarrassed. I must have an FM antenna fetish, because just outside my office on the deck here at my house, I have a bay of the Alfred antenna from the Empire State Building. Do I have a problem?
No, you'd fit right. You should come up and visit us sometime. You'd fit right in.
Would love to. In the summer. Would love to. Yeah. All right. I'm sorry. I didn't mean to sidetrack you. Go ahead.
Going to your point about the combiner, right? So, it sounds simple, like there's 13 stations going into it, but the bandwidth, the FM dial is only 88 to 108, right? So in those 13 stations, out of those 13 stations, 12 of them have an 800 kilohertz spacing. So to your point, those transmitters can't talk to each other. Well, when you're 800 kilohertz apart, that combiner has to do a lot of filtering so that you don't produce IM products, which are then going to interfere with the signals that are on the air. So having said that, we've been able to develop, to meet the 80 dB of FCC regulations of IM performance. And when that system went in, there was something like David Sanford did the IM measurements for us. He did a great job. There was probably 188 different samples that he had to do to validate that the combiner was compliant before these stations went in. So it was 2 nights of work validating that we had the proper isolation. So those transmitters, as you say, they were the only game in town. There was nobody next to them. They played beautifully.
Wow. All right. What's next on the hit? Oh, okay. Well, we have another product to look into, right? The Ring 360. Is that right?
Yeah. So the Ring 360. Here's what I challenge the team with on this one. Again, we're constantly thinking about how do we do things more reliably? How do we make it easier on the installer? And we just keep repeating ourselves throughout this entire show. But the Ring 360 is, traditionally, if you put a ring style antenna like the one that's on the page right now, or actually the previous page on the side of a tower, your vertical is no longer omnidirectional.
Right, because you have the tower in the way.
Because you have the tower, and the tower is a vertical element, right? Essentially, it's mostly vertical.
Mostly,
So it's going to push it's hard to get the vertical signal pass through the tower. So in a lot of cases where you're in the middle of a market, the broadcasters don't want the vertical to be suppressed by 12 dB or 20 dB or whatever it is. So that product is no longer viable. So the Ring 360, the challenge here was, how do we develop a ring style antenna, which has a lot less parts than a panel antenna, no cables, all hardline fed, a lot more reliable? How do we get that so it's omnidirectional horizontal and omnidirectional vertical? I think most of the engineering team was probably throwing darts at a dartboard with my picture on it after I said, here's the challenge, how do we do it? But if you go to the next slide, you can start to see, how we were able to achieve this. So the ring style antenna, or the dielectric ring style antenna, has a constant phase front all the way across the element, which helps us in this particular design. But and it's omnidirectional.
A constant phase front. I'm trying to imagine what a constant phase front looks like. What is that?
So essentially, I took the slide out to make the deck a little bit.
I hear you. I'm sorry.
Easier, but essentially, if you see the element on the where it shows the two omni directional, the input's to the left. Essentially, you can put that input in any direction, and as long as the elements are in line, you're going to get the same pattern.
Oh, okay. Yeah.
So what this slide is showing, though, is the what we call our DCRM or DCRU element. It's omnidirectional, both polarizations, until you put the feed line, which is vertical, and you put it on a tower. So a lot of the ring style antennas have a plot that's like to the right, where your horizontal and vertical are no longer omni. You've got a good, probably strong signal, 180 across that market, or DMA, but on the back side of the tower, it's hard to get signal through because it's a vertical structure.
Yeah.
The top is how we get around it. We make giant panel arrays that they multicast of. There's usually 3 panels around on a 6-foot mast or whatever, and that will produce your omnidirectional. So that's traditionally what you see in large markets in the center of cities. So what we wanted to do is put a ring style up. It's 66% less parts. It's very reliable. It's what most of the broadcasters are deploying on most sites that aren't master sites. So if we go to the next slide, this kind of shows what a traditional DCRU would look like on a pole. That pole is vertical. The feed system is also vertical. So if you had it top mounted, you'd have a vertical. In the left example, you'd have a vertical going 90 degrees, and you can see it's pushed. The horizontal stays omni because most of that structure is vertical. Now, because we have a constant phase front, and we go to the right, that signal's pushing to the left, or at 270, the vertical is, your horizontal stays omni. So as we're going through, as we're going through all these iterations, we're starting to think, okay, how do we keep these bays in line and build a structure so that this becomes an omnidirectional antenna? So if we go to the next slide,
I'm going to stop you right there because this is a great place to put a commercial. I got to tell you. Go ahead. Yeah.
This one is, I'm super proud of the team on this one. This is mind-blowing on what we were able to do. It actually became a lot more simple than we thought it was going to be. I just wish there was more demand out there for this type of application because it's an absolute home run.
I got to tell you, audience, fellow engineers, when you see the next slide, you're going to go, oh my God. So that's how they do it. And I've seen the slide, but You haven't, unless you're at the Wisconsin Broadcasters or you work for Dielectric. But we're going to have that slide for you and show you how we make this. How Keith and his team at Dielectric make this Omni, even though there's a tower in the way, and it just blew my mind. When I saw this, I went, "Holy cow!" We got to show that. All right, our show This Week in Radio Tech brought to you in part by a couple of great sponsors. One of them is Angry Audio. Don't get mad, get angry, get Angry Audio, and you know how much I love their stuff. And one of the things that I really love is their Rave audio console. Now, they've been shipping this puppy for about a year now, and it is gorgeous. Not only gorgeous, it's really heavy duty built. I mean, you got to use both hands to lift this thing because it is made out of some strong metal, and it's just brilliant the way it clamshells together with the buttons and LEDs and faders on the top and the electronics on the bottom. It is just so cool. I'm telling you, Mike Dosh is a genius in the audio console world. And you're going to love this audio console from Angry Audio. It has things like 2 stereo output mix buses, program and audition. That's pretty standard. And it does have preview or cue on every input. Channels 1 through 4 are switchable between mic and line, and the mic preamps are built in. And they're on XLR connectors. On-off buttons are slightly recessed, so you prevent accidental actuation there. So really intelligent design here. Channels 5 and 6, they're switchable between Pro levels and IHF levels. IHF, what's that? That's the -10 level that you often see with unbalanced designs. It has an ergonomic wrist rest. Channels 7 and 8 are capable of mix-minus. There are 2 mix-minus outputs with talkback. On-air indicator that lights up when the mics are open and the monitors are muted. That's right on the console. You can see on the console, hey, is there any mic on, right? Dedicated meters for both of the output mixes. Long throw faders for the monitor and for the headphone volume. So that's pretty cool too. And around the backside, it's got the Studio Hub connectors for all of your audio, except mics. They do have XLRs for the mics because people want that. And the mic preamps are just studio grade. They are amazing. Plus, you can turn on 48 volt phantom power for your mic preamps. So they are very low noise. You got to check this thing out. This is just a beautiful, beautiful console. The Rave, it's totally analog. It's an analog console. It's great for podcast production. Of course, you can use it on the air, production rooms. But man, this console is really beautiful and built. You shouldn't have to replace this console as long as you're in the business. It is really well built. Check it out from Angry Audio. The website is angryaudio.com, and of course you can buy it from any of your favorite broadcast equipment dealers. All right, next I want to talk about our friends at Max Connect. One of the things that Josh Bone, the owner of Max Connect, he has done is he's made a partnership with Audio Science, and Audio Science makes this tuner card that is super duper flexible. Well, they have several different models. There's an AM and FM and weather band model. There's an AM/FM and AM/HD/FM/HD model, and these have separate antenna inputs for the 2 different kinds. Of course, if you have different antennas that are optimized for receipt of AM and FM and weather band, but he's put all these into a 1 RU box. It's called the Max Connect RMT 416. Because it can be up to 16 receivers. You don't have to buy 16. You can buy it in smaller quantities if you want to. It's available with different numbers of tuners in it in blocks of 4. But man, this thing is so cool. One of the you can remote into it with a web interface. That's pretty cool. So you can tune the tuners, lock them in. And speaking of lock them in, you can lose power, and when it comes back up, they're on the same stations. Isn't that important? I mean, how many times have you fussed with tuners for your monitoring off air and you lose power or unplug it or something and you got to go retune it again, and nobody at the station but you, the engineer, knows how to do that. So check this out. You can monitor all of it also with SNMP. If you are into SNMP, you got that. Oh, each tuner will stream as well through an built-in IceCast server. So yeah, you can listen remotely with no problem. Check out just all the features at the Max Connect website at MAXXKONNECT, Max Connect. I know it's spelled funny, but there's a link in the show notes. MaxConnect.com. Check it out. Yeah, there's some features right there on your screen. Man, up to 16 tuners at once, and it is so cool. yeah, check this thing out. Gives you lots of data too about each signal and how well it's doing. Thanks, Max Connect, for sponsoring This Week in Radio Tech. Check out all our services, especially Max Connect Wireless, to get you reliable 4G LTE data where you need it, like transmitter sites or remote broadcasts. All right, it's This Week in Radio Tech. I'm Kirk Harnack. Our guest is Keith Pelletier, president of Dielectric. And Keith, okay, I know it's quite a buildup, but I thought this was just brilliant. We've talked about, antennas and how the vertical structure really, keeps it from being an omnidirectional signal in the vertical plane. The horizontal's not as affected at all. So you've got on the slide that we were looking at, we had what almost looks like two mirror images, whether the bays are mounted on one side of the tower or mounted on the other side of the tower. I'm not sure if Suncast can throw that one up to remind us where we were. This is the one there. What slide number? Yeah, there you go. There you go. But, if you look at this, you kind of might notice that the vertical patterns are complementary.
Absolutely.
What can we do with that?
What are we doing with that? Absolutely. So if we go to the next slide and we reveal what we're doing, you can see that. So as I said, the phase front of that element is the same across the board. So now we're feeding the bottom of array facing towards the east and the top array facing towards the west. And when you do that, now your verticals, kind of like when we said we were rotating the panels, it becomes very omni. And you can see the results of this. And it's quite, I make it sound really easy, but the mechanical team had to come up with quite the structure here to be able to make sure that we could build this and it would stay on the tower top as well. But the results are, almost pure omnidirectional. And if you look at what typically is done with us and most of our competitors, you can see on the bottom right is a 3-around panel. So they have some scalping, some nulls. So it also is not perfectly omni.
Right.
And I think the Ring 360, we outdid it. It's going to be a much better performing system in a major market with good omnidirectional results. Simply a ring style antenna. So the parts count is down by 66%. It's something that we build for broadcasters every single day. And you can see we kind of got a dogleg mechanical structure. And because you're doing that, the top is going to want to tip it over. So that third transmission line is a counterweight. And we can do those in berry sections or, strap that counterweight on the face of the tower. There's many different combinations that we can do. But again, when this is completely installed, we're very excited about it. We don't have one sold yet, so hopefully it won't be long before we do. But I think this is a complete game changer, thinking way outside the box. I don't even think we could see the box when we first started doing this. So very excited about this development and what we can do with it moving forward.
I like the fact that you point out here, right on the slide, patterns incorporate real pipe sizes. What does that mean? That it's, to me, it sounds like you're trying to say the pipes that support this, steel pipes, these are not necessarily custom fabrications for the support structure. This can be off the shelf sizes. Am I close?
Yeah, it's that, and also a lot of the stuff that we do in design today is computer generated. So a lot of the Maxwell equations that we've been talking about throughout this show is being solved by the computer. We can run simulations overnight. The engineer can launch a bunch of results that he wants, and then move on to the next, or she wants, and move on to the next project. So the HFSS has gotten so good over the years. Like, just to take a step back, and when I first started, we had HFSS, but you could only draw squares and cylinders. So anything else, you had to kind of make up what that would look like. You'd get it close, you'd launch it to the manufacturing side, which took a lot of machining time, a lot of production time, a lot of tweaking time. Today, we can design solely in HFSS make it to what it says, and the manufacturing floor is golden. They're good to go. So one of the things that I like to say on all of that is, I mean, if it can be solved on the manufacturing floor, our philosophy is bring it to the engineering team, solve it 100% like you couldn't 20 years ago. Mm-hmm. It allows your engineering team to continue to develop more products that the end users want, and the manufacturing team doesn't need them. And they always need them, but at the end of the day, if they're not on the floor trying to fix stuff that doesn't quite work, we're producing more stuff moving forward. And that's the philosophy that we've changed over the past decade. And with tools like drone studies and other things that are in the field, we've been able to validate that our systems are working exactly the way we say they were. So, I mean, over the past 3 decades, things have changed so dramatically, and Dielectric's just trying to take advantage of all the tools that they can to better themselves for the end users. And some of these products that we talked about today is living proof that we're doing that. So it's very exciting. It's things have come a long way, and we're always trying to push the envelope to make sure that we keep doing it. As another example, it's a TV example, but we had a customer that had a TV antenna that was had a specific pattern, and they asked if they could change the pattern on that antenna in the air, in the field at 1,500 feet up. Mm-hmm. 25 years ago, we're saying that antenna needs to come down. You're buying a new antenna for, with rigging and everything, it's probably $1 million project. We were able to take that, redesign a few components of that antenna, put a new slugging section, and give the customer exactly what they wanted. That's just vastly unheard of. So it's those types of things that if we continue to challenge ourselves, there's always risk involved. We have to evaluate the risk, but those are the types of things that we do on a daily basis that really try to separate ourselves from our competition.
I have a question. If Suncats, if you could bring up the very last slide, and that was going to be our next one anyway. We have 8 bays on the top and 8 bays below, each on a different side of their support structure. Are each of set of 8 bays, are they precisely aligned with the other set? I mean, if you're looking down from the top, look straight down, that they're all aligned with each other. Okay.
Yep. I didn't mention this on this one. This is a half wave spaced dual section. What I didn't say here is the Ringmaster technology can be put on this as well. So it can be full wave, it can be half wave, it can be Ringmaster, depending on the customer's configuration. So it's very flexible design.
I would like to. We don't have time for an explanation on this show, but it'd be neat to kind of understand how the when you first look at that, you're not sure. You say, "Oh, that's a lot of weight over on that one side. That's going to make a lot of stress right there." And then, hey, think about this, fellas. You go to a high school football game or a college football game, and what do you see? You see the hunky male cheerleader holding up the spinner, the flyer, with one hand, right? And of course, he's a bulky guy. He's got no problem, holding the cheerleader up above his head. Same concept, except this is steel and not a guy, right?
Yeah, absolutely.
You probably hadn't presented it to your engineers that way, but it apparently it does work out, obviously. I think you already went through most of these bullet points right here when you mentioned the benefits of this design.
Yep. Yeah. Just so, we can recap them again. Simple solution that solves a very complex problem. Better performance than a typical panel array. Much less parts, which leads to reliability. Parts count directly proportional to reliability. 10 times more reliable than a panel based on the part count reduction, and it's adaptable to many other configurations. So Ringmaster, full wave, half wave, different lengths. You probably, based on mechanical designs, that 90 feet's about the limit based on being able to make sure it's robust and sturdy on the tower top. But if a customer has the need for a much lower gain, you can clearly make that at 45 feet or 35 feet or 60 feet. So just really exciting stuff. And again, everything that we showcased today, plus the reconfigurable manifold that we talked about briefly, it's all patent pending technology by Dielectric.
Yeah. Very nice. Very cool. Well, as I mentioned, Keith, we're about to run out of time. We've got a quick commercial, and then, Keith, once again, I forgot to tell our guest, you, about what's expected for the final little short segment. Looking for a tip of the week, and it could be maybe some feature on your website. It could be some helpful thing online, or just some helpful advice. What would you like to leave our listeners with? And you've got 2 minutes to think about it, because that's when we're going to come back from our commercial. So Keith is going to have our tip of the week, I promise you, even though I just now told him about it in just a couple minutes. This Week in Radio Tech is brought to you in part by our friends at Broadcasters General Store, and you can get just about anything you need for broadcasting from BGS. The website is bgs.cc, and one of those things, they carry the whole line of broadcast tools equipment. And one of those pieces of gear is something that is so useful. And if you don't have a good way to monitor for silence, we got so many radio stations now, and we're not tuned into all of them all the time. Back when all you had was an AM and an FM in a given town, it wasn't so hard to monitor those. But when you've got a bunch of stations, you might want to use the Audio Sentinel plus WebRJ web-based analog silence detector from Broadcast Tools. It's got a built-in web server. That's cool. It provides simple web-based notification, monitoring, configuration, and control. It's powered by a high-performance ARM processor. It does have support for Start TLS secure SMTP authentication. So in other words, it'll work with Gmail. It'll send you an email if there is silence on one of the program channels. Front panel, remote, and web-based switcher controls. It has both stereo inputs, features silence sensors and phase monitors with front panel activity and alarm LED indicators. Hey, maybe you take a satellite channel that occasionally they get the phase wrong. That's no good for your mono listeners. So you can be alerted to that. Silence trip detection, that threshold is easily settable. Precise time delay for each channel, and has an internal transparent 2x1 switcher with mechanical latching relays. If you need to emergency, switch to a different input, you sure can. And if power is lost, well, the last selected channel is passed to the output. So it remembers that because they're mechanical latching relays. Email logging of system status, pluggable screw terminal block, and RJ45 audio jacks are on the back. All that's fully RFI proofed, so none of Keith Pelletier's antennas are gonna get into it. It's gonna remain clean, and it's surge protected internal power supply, universal switching supply, and this is just all very well built. Things that are built by Broadcast Tools, by Don Wingett. Oh my goodness, good stuff. So check it out, and the place to get it, of course, is from Broadcasters General Store, bgs.cc. They're standing by the phones right now if you need to call them, 352-622-7700. These are good folks, and I bet you I've bought 25 radio stations worth of gear from Broadcasters General Store. Love these folks, sharp pencils, and really friendly service. Check them out. All right. It's Kirk Harnack, and we're reaching the very end of this episode with Keith Pelletier from Dielectric. Sorry, Keith. And Keith, I want to see if I can impose upon you now to give us a tip of the week.
All right. It's kind of self-promoting here, but we talked a little bit about our manifold combining, and I'm as excited about our manifold combining as I am all the antenna developments that we've done. It's really cool technology. We could do a whole nother episode on this in the future, but I'll leave you with a little bit of a teaser. Visit the Dielectric website, dielectric.com website, go to resources and technical resources. There's a manifold combiner that kind of goes through, it's a 7-minute video that basically goes through what we're trying to do or what we have done in order to make the manifold combiner a lot more economical and easy for the broadcasters to be able to expand. It goes into a lot of the different details. But I think a lot of people that are watching this show would appreciate going to watch that, and it just showcases something else that we've worked on that's pretty unique and didn't think was achievable when we first started. So that's my tip.
I have already found it on YouTube, but I will post the link to your article and your page on your website so people can go there, and then I guess they can click to see the YouTube video about the FM manifold combiner, right?
Yep, absolutely.
Does that combining technology, does that work well with other frequency bands? Could you combine some TV stations with that, or is it really work best with FM?
That's a great question. And it kind of goes back to what I said earlier, is that, a lot of the techniques that we're using in TV and FM, they're different frequency bands, but you can use the same techniques as you go through that, the RF spectrum. So based on power levels and based on, size, they look different. But yes, you can apply this technology for the television band and other parts of the RF band as well.
Okay, good deal. Keith, if broadcasters want to check out, get a quote, or talk technical about their needs for an FM antenna, how do they get hold of you guys? Website?
Yeah, websites is a good way. Jay Martin's our VP of sales. He's got a strong team behind him. Corey Edwards is driving a lot of this FM. And we're also partnered with SCMS. So we get a lot more sales guys, boots on the ground. They're bringing a lot of opportunities that we wouldn't see otherwise. So, come to the website, contact one of our sales guys, or contact anybody at SCMS.
Good deal. Thank you so much, Keith. I really appreciate you sharing the most of the information, or a lot of it, that you shared to the Wisconsin broadcasters. And I've just found this to be fascinating. I really appreciate you taking the time to spend with us and our audience.
You've got it, Kirk, and I really appreciate the time as well. And this has been a great hour. So hopefully the audience enjoys it as well.
I'd love to schedule a time with you next year sometime to talk about this manifold combiner. But in the meantime, we'll send people to the website to see the video about that.
All right. Sounds good. And have a great Thanksgiving.
Thank you very much. Keith Pelletier, the president of Dielectric, has been our guest. And Suncast has been our producer, as usual, for the show. Suncast, thank you again for a job well done. Appreciate that. Next week is Thanksgiving. And next week, we are going to pre-record a show with a bunch of very thankful engineers. And I think it's going to be inspiring. Then you're going to want to see this. We're going to play it back at its usual time on Thanksgiving Day. So Thanksgiving Day, 5 p.m. Eastern time, we will have a show. We won't be doing it live. It'll be pre-recorded, but it's going to be fun, and you're going to enjoy it. And of course, you can always pick it up later on. Watch it sometime, after the turkey, if you on Thanksgiving weekend. So we'll see you next week on This Week in Radio Tech. Bye-bye.